Good day, fellow judges. My name is Chong Wai Hong, and thanks for giving us this opportunity to present despite having the COVID outbreak. So, what my project does is basically utilize this polymer-coated magnetic nanoparticle to remove dye wastewater. So, the first question arises: why do we need to treat dye wastewater? This is an example of industrial dye wastewater. When these wastes are not treated properly and physically exposed to human being, it will cause vomit, jaundice, and even quadriplegia. Commercially, there are many ways to treat this dye wastewater. For instance, flocculation, oxidation, electrolysis, and adsorbent. In this study, we focus more into adsorbent. So now, the second question arises. Why do we use adsorbent instead of other methods? That's simply because adsorbent itself is smaller in size, which contributes to larger the surface area to volume ratio. Besides, adsorption process itself is really simple, but still, there's a disadvantage in it. After the adsorption process, the separation process of the adsorbent from its effluent is really difficult, and centrifugation is needed, which is really expensive. So that's why we come out with a second solution, which is to use magnetic nanoparticle. Why? Because magnetic nanoparticle itself has magnetic properties, which greatly helps to cut down the cost, because its process is really simple, the separation process. And how perfect it is, there is still a problem in it, which is the agglomeration issue. So now we know that agglomeration issue is a problem for magnetic nanoparticles. But what exactly is agglomeration? Allow me to explain using this short animation. So following shows magnetic nanoparticles, and when these particles are introduced into an external magnetic field, they tend to agglomerate, which is to club together due to van der Waals forces and magnetic attraction. So this agglomerate will greatly reduce its total surface area, surface energy, and hence its overall operating efficiency. So how do we overcome this agglomeration? Here comes the first highlight of this project. So first, we will introduce this PSS polymer as a coating agent. We coat this PSS polymer on the surface of magnetic nanoparticles. So how does it help? This electrostatic charge of PSS will induce repulsion with each other, and this will greatly help to reduce the agglomerate form, and hence it will increase the total surface area, overall surface energy, and of course, it will greatly increase the operating efficiency. There's one more highlight. This polymer will help the adsorbent to be chemically stable. What do I mean? Basically, the electrostatic charge of it will not change across two extreme pH. So now we understand this polymer can reduce the formation of agglomerates. How does it actually remove dye in actual situation? So following is another short animation which portrays the mechanism of dye removal. First, the metallic blue, and when this PSS coated MN piece comes in contact with this metallic blue, the opposite charge of both of these substances will induce electrostatic attraction, and when magnetic field is introduced, metallic blue adsorbent will be magnetically attracted to the magnetic source, and hence no complicated centrifugation needed. All we need is just the magnetic field. It's simple, energy saving, effluent is free from these constituents, and lastly, it's really cheap and the operating cost is really low. Next, we compare the dye removal efficiency of naked particle and the coated particle. As our results shown, there are 94% pollutant removed using the coated ones, unlike the naked ones, which reach around 65%. Here comes the last highlight of this project. This coated MN piece has regeneration capability, and it is made possible by addition of really low dose of hydrogen peroxide, which induce Fenton reaction. At least 4 adsorption cycles reach with 85% pollutant removed each cycle. This is very practicable and feasible in economical applications. Unfortunately, our research team was able to publish this project recently. That's all for my project. Have a nice day.